Greetings to all. Welcome back to the course on Introduction to Electric Vehicles. So we will be starting module 4, and in module 4 we will be covering up these topics. So the first topic we'll be covering is energy storage systems or ESS. So in this we'll be learning what are the type of batteries, how a lithium cell works, and the features of batteries. In the second part we'll be learning about the battery management system. So if there are hundreds of batteries or hundreds of cells aligned, how to manage the charge in all these cells? So there comes the concept of state of charge, state of health, or state of life. Then in third part, we'll be learning about the modeling of batteries, and especially we'll be focusing on electrochemical method and or electrical method. Then we'll be covering the overview of charging techniques, that which charging techniques are better and which charging techniques are currently in use. And lastly, we'll be doing a MATLAB Simulink model or a small project where we'll be doing active charge balancing using a flyback converter. So let's hop into the ESS or the energy storage systems. So in energy storage systems, we already know that currently in India or most of the vehicles which are being used are of IC engine based. So if you talk about the figure, then almost 95% world of the vehicle worldwide are using IC engine right now. So there are petroleum, natural gas and biofuels which are being mostly used. So internal combustion engine or hybrid electric vehicle uses these two forms of energy. Which forms of energy? One is coming from the natural resources like petroleum or coming from the electricity. So this common part is known as a region for hybrid electric vehicles. So what is hybrid electric vehicle? So a hybrid electric vehicle is a vehicle which uses both this energy. It can use petrol, diesel also, and it can use electrical energy from battery also. So, and then comes the pure battery electric vehicle. So pure battery electric vehicle uses battery as a energy source. So it uses only battery as a energy source. And these vehicles are also in demand and their demand is continuously increasing. And the other type of vehicle which is of prominent interest of the researchers are fuel cell electric vehicles. So the fuel cell electric vehicles, there is a device or a component called fuel cell which converts hydrogen into the electrical energy. And here hydrogen, being a very good source of energy, is being used as a energy source, and fuel cell is a conversion device which converts the energy from hydrogen cell to into electrical energy. So these kind of energy sources will be used in future, and it is also known that hydrogen will be used more and more in the coming future. Currently the technology related to hydrogen is not that mature, so it is still in research and development stage. So now that we know that these are the energy sources, we will be now focusing on the battery and its type. So why battery? Because most of the vehicles which are being the electric vehicle which are being marketed or which are being promoted are either battery electric vehicle or a hybrid electric vehicle. So the electrochemical energy storage system which is being used in most of the vehicles uses mostly battery as an energy source. They can also use ultra capacitor or fuel cells, but ultra capacitor, the energy density is not that much, but power density is higher. So batteries can be of many types. So the most common battery which we have seen at our homes also in inverters was lead acid battery. Then the nickel based battery is also popular, but the most interesting battery or the which is the most used battery is the lithium batteries. So lithium batteries, why we are using lithium, we'll be learning in the next video. But lithium batteries are the most popular batteries. So lithium battery can be basically a lithium-ion battery where lithium is one part of the battery and other part can be graphene or the any carbon-based part or a graphite. Then comes the lithium metal batteries. So most of the batteries which are being used are lithium-ion based batteries, and lithium metal batteries are also in use currently. But there are also other kinds of batteries which are getting interest or which are being pushed by the companies or the research agencies. These are high temperature batteries like sodium beta battery or high temperature lithium batteries. And another interesting battery which will be coming in a few years are metal air batteries. So metal air batteries possess a huge potential for being used in a battery electric vehicle. So currently we are here at lithium batteries, but we are slowly moving towards the metal air batteries or the lithium air battery or the aluminum air or sodium air. These kind of batteries will be coming in near future. So this is all about the batteries. Then this course do not focus on the fuel cells or the hydrogen electric vehicle or the hydrogen vehicle. So here I have shown a basic method of how to these fuel cells are, how many types of fuel cells are there, and what are the methods to make them. So this is just a basic structure diagram. Now we have learned that what are the energy storage systems used for running a vehicle. So we zeroed down to the three main type of energy storage. First was our fuel, which was our fossil fuel. Second was batteries or any kind of electrochemical storage system. And third time is fuel cells, which is basically hydrogen based vehicles. So these are the three categories we have broadly defined. Now we'll be focusing only on batteries. So why we are focusing on batteries? Because most of the manufacturers worldwide are using batteries, and that too is a lithium-ion batteries. So whether it is a hybrid electric vehicle like the Renault Twizy, where it is using a low capacity of battery, or it is a full battery electric vehicle like Tesla Model S. So Tesla Model S is a full battery or a pure battery electric vehicle where all energy is coming from the battery alone. So this will use a high capacity of battery, that is 100 kilowatt hour. Okay, similarly Hyundai Ioniq or Nissan Leaf, these are also a type of battery electric vehicles. So the basic question arises is why lithium ion, and why lithium ion is the most popular choice of the most of the manufacturers. So here is a graph shown where we can see that there are two important factors which drives batteries, or which makes a battery more potential for the use in battery electric vehicle. So number one is the energy density. So energy density and the power density, two things should be there in a one battery. And as you can see, this is energy density and this one is power density. So as you can see that lithium or a lead acid is at the bottom of the chart. So these were the old batteries which are still used in inverters, or in some cases integrated starter generator used in the trucks or buses. Then nickel cadmium or these kind of batteries were coming up. Then we see the lithium ion is topping the chart when it comes to the energy density. So currently energy density of good lithium ion battery is somewhere around 300, and this is in near future will be increasing up to 500 or 600. So there's a target that every 4 years the battery capacity should increase to double and the price of battery should come to half. So then only the target of getting electric vehicle to every household will be getting more and more feasible, or more and more closer to the target which the government have set. So the worldwide government have set a target of 2030, 2035 or 2040 to completely replace the IC engine with the battery electric vehicle, or at least the plug-in hybrid electric vehicle. So this is why the lithium ion is the most used battery. And the lithium metal or the metal based batteries are consist of more energy dense, but the main problem with metal based battery is they are unsafe. So currently they are not used, but as the R&D will or the research and development will progress, it will be used more and more. So how a lithium ion battery works? So here there are two figures. So this is figure A and this is figure B. So in figure A we can see that there are lithium ions here on the cathode side, and on the anode side we are using a graphite. Okay, so graphite structure is shown in anode. So whenever the charging happens, or here the electrons, here the discharging is shown. So whenever the discharging will happen, the ions which are being trapped here, lithium ions which are being trapped here, will move towards the cathode side, and during charging the lithium will will lose its electrons, and the electrons will be going towards the anode side. So here the separator is shown, and you can see that when charging is happening, the lithium ion are crossing the separator or the separator and going towards the graphite. So this graphite stores all this lithium ion, and till you discharge the battery or till you use the battery next time, these lithium ion will be saved in the anode or in this graphite structure. So this graphite structure will save the lithium ions, and when you will be using battery next time, this lithium ion will slowly move towards its cathode side, or where the lithium is, or the whether that composition of lithium cobalt is put, which is in the cathode side. So lithium ion works on the basic concept of electrochemical potential, which is lithium has a, the electrochemical potential is a tendency to lose the electron, and lithium is the metal which has the highest tendency to lose electron. So this is how a lithium battery works, and because the tendency to lose electron is highest in lithium, that's why lithium is used, not any other material is or metal is used. So this is a lithium ion family and why they are popular. So a lithium ion battery is used, there are many type of lithium ion family, and many type of batteries are inside this lithium ion family. Out of these, the most popular are the lithium iron phosphate or LFP batteries or the NMC batteries. And why these two are popular is because LFP has a very good specific power and lifespan and safety. These three things makes this LFP battery more and more safer to be used in electric vehicles, and also the lifespan is higher. And NMC battery are mostly used for the performance based, because the specific energy or the capacity of battery is higher. So these two batteries are used depending on the positioning of the company. If company is saying that we will be using a safe battery and we have a higher lifespan, so they will be going with the LFP. And if the company is a performance based company, like they are saying that we will be giving you a high performance vehicle, then they will be going towards the NMC battery. Other batteries are also there, but mostly these two are currently popular. So LFP has a more ability of thermal stress. That's why it is more safer, because it can take a more of a thermal stress. So which are the technologies which are being used in the, or which will be used in the future? So battery technologies which are beyond lithium ions are, which we have already discussed, is metal air batteries. So these metal air batteries consist of some metal like aluminum and air on the second side, and in between there is an electrolyte or a separator which is separating these two things. So this, here we can see that the metal air batteries, the energy density or the theoretical energy density is very higher, and especially if you see this lithium air battery, the energy density is 11,400, which is more than the petrol. The energy density of a petrol or the gasoline is in the range of 9,000 to 10,000. So it is similar to the petrol. So the energy density which is coming with petrol, which is very high, so we can go up to that much if we can invest more and more on research and development. Currently, the lithium ion batteries which are being used, their energy density is somewhere around 250 to 300 kilowatt hour per kg. So this is basically currently which are being used, but in future you can see that we have a theoretical value of 11,000 also. So in future we might move towards the metal air battery. Okay. Second, batteries which are high temperature batteries, or which are sodium beta batteries. These batteries are the good thing about is they work in a high temperature. They also work in a high temperature. So this battery, which is a diagram shown here, this is by a company known as BASF, and this company has registered this battery name, or sodium beta battery, with the name NAS. This battery is known as NAS. So we are not going into the working of these batteries, but you should know that these are some batteries which will be used in future. And one battery is sodium metal chloride battery, and these are all sodium based batteries basically. So there are two categories. One, sodium based batteries is also under research, and metal air batteries are also under research. So basically we'll be going either with the metal air or with the sodium based batteries. So this is all for this videos, and we'll be learning more about the battery management system from the next video. Okay. Thank you.